Yes, good evening, ladies and gentlemen. Yeah, this is me again, Engineer Ochola. I think I'm still loitering around skew angled structures. Now I'm trying to look at the relationship between a skew box culvert with the normal slab bridge, and also maybe similar to the T-girder skew deck bridge. So when you look at this is a skew culvert with both the obtuse and acute angle, and then also you find, actually, because of the orientation of the road, you find now water going here, and then this is the road. These edges are aligned to the road. This one has a cushion of about 1 meter or 1 point something. So when the cushion is above 0.6, we normally do patch loading instead of doing a traffic load and the wheel load directly on the bridge, on the top slab. So basically that is how it is modeled. You can use the normal RC boxes here. You can actually quickly show you here. The box is here, the skew angle is here, and the box is here. So you can specify your skew angle and specify all this. The transverse loading, the deck slab, you can indicate here, and then the loads, and then you run your stuff and do other modification. Yeah, so basically this is what we have. And when you look at the previous deck slab we looked at, I can quickly pick a similarity here, and then we look at it quickly. Then there are some two areas that I thought they are similar that we can also appreciate. So definitely this is your top slab skew, and it has a support like a beam now here, so like the 4 running beam parallel to this, and this is the road, this is the river flow or water flow. So when you look at the results, and then you look at the deformation, not deformation, like go to my moment, plate moment. It's good. I just want to do, okay, axial load pressure. So the axial load pressure, when you look at it here, where is the pressure? Axial load pressure is here. That is the axial load pressure. It is idealized as the cushion and applied within the road width band. So that is what we have. So basically that. So I'm looking at the moment. So how are the moment distribution in relation to what we looked at earlier? So basically this is how, because of these beams, you see these are hogging areas. So if I can quickly look at a bit of a cut, if it is there. Oh, so you find that I was trying to cut diagonal also, because I'm trying to compare and see the behavior. So I'm just trying to, so this is a cut, that's the diagonal. So it also has a bit of moment at the end, and this one, and then you have the hogging, and then that's the acute angle. I want also to look at the obtuse angle and compare. There we go. So you can actually find that actually if this is the acute angle, which is the 50, is having a 58 kilonewton meter, at the obtuse you are having twice. So my worry now is slightly being resolved, because I thought maybe the parallel beams here would have some restrainment, but look like the behavior doesn't change. So basically that is what you have. And I also see, okay, these are all hogging, this is also hogging, this is also hogging, and that's the bending. So this is bending. So basically the obtuse and acute angle, even when you're handling box culvert, please try to be very mindful, because if I check reinforcement here and I compare with this, it will be different. So let me pick it and we see. So because here I think I've gone slightly further, and I can actually do a design which was already done. Then I look at that particular section here. I think the worst case should be, let me do this one and this one, then maybe so this is going to be the obtuse. So when I go to my design, I look at the plate. Top slab is given, detail and graphics. So from graphics, you find actually here that we have T25 at 100, but we could still reduce. So this is what I have. I want now to compare. So this is what you have, T25 at 100, which is passing, but is that the only thing? So what I would do, I can easily go back here in the plate, rebars, and then I try to look at the top slab, and I can do maybe a 20 here, and then the distribution, that's 16. I can do 0.2 here, 0.2, modify, then I go back to the main bars, I do this to 0.2, so 0.2. I'm just trying to check and see. So having done that, I go back now here quickly and try to see. You find actually, because it's only 124 and others were high, so you can actually do your check, optimize, and see what works. So I have reduced this to 20 at 200. Definitely you also need to check that the crack width is passing. If it is not, then you have to adjust. I can now see something at 0.0. This is the check ratio, of course, Beckett is 0.003, so you may find we are still safe. So if this is the case, I want to find out so you find if this is giving you 20 at 200, this is a half, so this can actually give you 100. I can see, let me first check this further. Top slab, I can do this to 16, I can do this to 16. This one 2016. Then okay, this one modify, and then distribution I can put 12, and then because this is now how you can do your optimization and you detail it properly. It's very important. So now I'm able to go down here quickly and look at the plate. So it's giving me this. Let me look at my crack width. I think I'm still fine. This one is okay. So 16, because this is actually low value. Even 12 or something can work. So what I'm trying to say is this moment is high. That means now on the other side, it will be slightly lower. So that is, I wanted to find out exactly if plate rebar here, I want to look at my top slab, and then I'm now doing 12, modify, then also distribution, I think this 12, modify, close. So I can quickly look at this. So moment ratio 0.0, stress is here. shear capacity is now 0.92, though the moment. So you know this is very important. Sometimes you may think it is moment capacity, but shear can take control. So if I look at the 0.94 as the ratio, then I need to limit it here. So that would mean this one I would give me this one will give you T12 at 200. What about this one here? It will go further. So now that means now if someone is raising concern about quality assurance and maybe optimization, you can easily come and try to zone this slab and see how best you can sort it out and make sure the design is optimized, and then try to come up with what is it has value for money and fit for purpose. So this is what I'm trying to say, that now I can actually check this, and then I can also check for this. Then that because it is already you see, so you see something is not right. As much as here it is high, now this is not very interesting. You can actually check these graphics, and it's telling you that actually the moment capacity. Now that means now there is some kind of, you see, is giving us, it has passed by some. So it means the low value and the angle here may not necessarily mean now it has to have the same behavior. That's why it requires careful consideration. It is not. So it is very important that this is understood. So what do? We go back to I can do 12 at 150. So when I do 12 at 150, it might resolve the issue, and therefore you can easily handle corner bars. So I find here I do a 0.15 and I do a 0.15. I'm able to just make sure I leave that, and then this is still okay, and I can quickly look at that. Yeah, but still rate, so not very much, but then you can check all these values. You may find this is 0.69, the shear is okay. Moment capacity is at 0.8. That is the top. That means here the top hogging is very important. So see, it has come down slightly. But what about also the crack system? Okay, stresses also are fine. So basically, it is very important. We don't need to rush with design. Spend some time and make sure when you have this skewness of the structure, you need to be mindful. This is very important. So let me stop here. At least you have understood something, that these angles do behave in a similar way. But also we need to confirm with the deck slab, which is a slab, does also have this similar, where you have a smaller moment, and then giving more because you find there's a moment, something is causing that reinforcement to be improved. That also is very. Then secondly, normally because at the edge here you have a deep wall going down, so normally the moment we take is not exactly the one at the center of the wall. It has to be off slightly so that you are able to get realistic. That is what I could say here. Let me bring back this, and then I want to also bring in, so you can now see the moment distribution vary. There is something I saw in this for the slab. They also have a similar behavior. You have for the slab you have that. So you find this this flaring one. You know, where you have obtuse angle, you have an angle which is slightly higher than or bigger than this one. So the obtuse angle here, this one of that, tend to be bigger than for this side. So the moment tend to be more on the obtuse of this than this side. And I realized that when you cut also a section, the wall, this wall, the vertical wall here and the wall here do experience wider, bigger load than the counterpart here and this side. So I realized that if you rush to pick a value here and design, then you will have under design your wing wall. So the wing wall has to be carefully looked at because of that. So I'm going to pick this and then this apron, and then we look at, you see now this moment, this is the obtuse area, this is the obtuse. It gives you 90 here, and this being is 25 at the lower point, and 15, this is also 15 and 25, which is the same. Here is almost 85 and 23. So that in a way is trying to indicate that this area here, and this area here are similar. So this area here and this area here. So basically now you can see the acute area. So this is 90 to 26, this is 85 to 23, this is 25 to, so the variation tend to be, the vertical pressure tend to be, or the moment tend to be higher, the value tend to be higher at the obtuse than when it is at the the acute of the deck slab and also the bottom. So basically those are things that actually the skewness can actually bring, and so one need to pay a bit of attention. You have to do some due diligence, need to check and make sure the things are correctly checked. And then even reinforcement pattern now matters. That as much as people rush to put reinforcement, the vertical bar coming with that, we need to pay attention on the where you have these walls and the walls and the walls and where these are intersecting, to make sure we do not leave room for unnecessary premature cracks coming from high stress. So these are very, very important, and I think we need to pay attention. So skew angles do play a bigger role in our structures, especially the slabs and then box culverts, and so we need to try to pay some attention there. I think this one at least now brings us to at least some comfort that we need attention. The message here is that we need attention to handle the skewness of the deck slab and the box culvert, and that also might affect any, even if it is a foundation which is skew. You have to be mindful of the orientation, the angle, so that you don't underestimate the reinforcement. And you also notice that sometimes it's not one moment that control design. Sometimes it is shear, sometimes it is crack, and so you have to pay attention. Thank you so much for listening. God bless you.